Hi, this is Matt Lansing, owner of Stone Innovations. I had a customer ask me what the percentage of resin is in a granite countertop. So all granite slabs, when they're quarried, are taken from the big blocks, sliced into slabs, laid down, coated with a thin penetrating epoxy resin to fill in all the little pits and inclusions, and then polished. So this customer was asking me what percentage of the granite actually is resin. So this here is an actual remnant left over from that customer's countertops. So I've taken 3 slabs, samples from the slab, representative of some different areas of the stone, so we can get a good idea of how much resin is actually in the stone. So we're gonna do this test 2 different ways. So the resin in the stone melts, burns off between 400 and 600 degrees Fahrenheit. So we're gonna take these 3 samples of stone, and we're gonna heat them to well over 600 degrees and remove any traces of the resin in the stone. And then we're gonna calculate 2 different ways what resin has been removed from the stone. We're gonna weigh them before and after, and then we're gonna calculate their volume before and after. Because the plastic resin is actually quite a bit lighter than the stone itself, so just doing weight isn't very accurate. So we're also gonna calculate the volume. So stay tuned, this will get interesting. Okay, so we have our 3 granite samples. I took each one of the granite samples and I put a notch in them so it won't disappear while we're firing it. So I got sample 1, 2, and 3. So we're gonna take each one of the granite samples and we're gonna weigh it in grams before we do anything. And we'll write it down on our little chart we got started here. And then we got a Pyrex dish. We're gonna calculate then the volume. We'll calculate the volume first before we fire it, and then of course, obviously afterwards. So the customer was claiming that 1/3 of the granite that we sold them is epoxy resin fill. So I don't need to be super accurate on the volume. It should be obvious if the material loses 1/3. So Pyrex dish will be close enough. Okay, sample number 1. There's a weight of 759 grams. Sample number 2, 809. Sample number 3, 786. Okay, now we're going to calculate the volume of each of the granite samples. So we're starting with 1,000 milliliters of water just to make the math easy. Now we're at about, I'll call it 1,300 milliliters of water for the sample. Okay, sample number 2. So we're starting at 1,000 milliliters again. I'll call that about 1,350. And here's sample number 3. So it's about the same size as sample number 2, so it'll probably be similar in volume. So we're starting at 1,000 milliliters again. Yeah, I'll call it 1,325. So here are the numbers with the weights and the volumes. Okay, now it's time to fire our samples of granite and burn off the resin. We gotta take them to well over 600 degrees. So let's get started. You know, this is gonna take way too long. Okay, this should work better. Okay, let's check temperatures. There's the heat gun. So 280 degrees so far. Keep going. It's 410, 380. Getting closer. 530, 590, 540. There you go, 630 degrees. 630, 650. So we're gonna let these cool down enough so we can actually touch them and they don't melt the top of the scale or cause the water to boil in our Pyrex dish. So we're gonna let them cool down for about an hour or so. And then we'll do the weights and we'll calculate the volumes. Okay, our samples have cooled down mostly now. They're still about 200 degrees, but should be cool enough for us to get our weight measurements and our volume measurements. So we'll start with piece number 1. So 758 grams. Piece number 2. 807. Piece number 3. 784. So you can already see on here the difference from before and after. So we had 759 to 758. 809 versus 807, and 786 versus 784. So about 2 grams different. So about the weight of a paper clip. Okay, now we'll check the volume of the pieces. So we'll check piece number 1. We're starting at about 1,000 milliliters of water again. And it looks like we're about 1,300 milliliters. So about the same as before firing. Okay, now we'll check sample number 2. We're starting at about 1,000 milliliters again. Aye, hot. And I guess I would call that about 1,350 again. Okay, now we'll check sample number 3. Starting at about 1,000 milliliters again. I guess I would call that about 1,325, which is the same number we had before we fired. So if we actually do the math of our results, the volume numbers stayed about the same because we're only doing rough approximations of volume, just looking to see if there was going to be a 1/3 difference, but there's not. So we'll go calculate the percent differences based on weight. So doing the math, so sample number 1, 758 grams after we fired, 759 grams before we fired. So we get a difference of 0.132% resin in that sample. Samples 2 and 3 running the same calculations, we get approximately 0.25% resin. So if you average them all out, you're still gonna be pretty low percent. Definitely not the 1/3% or 1/3 of the stone that the customer was claiming. Statistically, way less than even 1% of the stone is resin. If we actually grab the sample of the stone and we look at it, we actually, if you can catch that reflection of it, the reflection of the stone is still, there's no actually any voids, openings, anything in the stone to actually say that the resin was actually filling anything. Even these black areas are still 100% solid, showing that it was a natural mineral and stuff. Even the silver reflective areas are still 100% filled, showing that that is all real and natural stone. There is no appreciable amount of filler in this stone. I think the actual weight difference that we're getting is from the fiberglass resin that was applied to the back of the stone. When a lot of that fiberglass burned off, I think that's where the majority of the weight came from, but that's fine. It just still shows the proof that this stone had a very, very low amount of resin actually present in it. So I hope we all learned something today.